Hello everyone! Today we'll explain the capacitor boost oscillation circuit with animation. Watch carefully and you'll learn a lot about circuits. The circuit uses 1.5 volt power and boosts through capacitor C2. This lights a 1.8 volt red LED. Let's explain the working process in detail. When the switch is open, voltage is across C1 and C2 or 0 volt. When the switch closes, it's like an AC surge, voltage rises quickly. The faster the change, the lower the capacitive reactance. At power on, C1 acts like 0, then Q1 base voltage equals the division of R1 and R2. Calculation shows Q1 base voltage is below conduction level. Q1 and Q2 are both off, also supply voltage is below LED turn-on voltage. No current flows through D1 and the LED. The circuit charges capacitor CE through R1 and R2. When CE voltage reaches about 0.7 volt, Q1 and Q2 turn on. Q2 collector current flows through R2 and voltage across R2 rises. When C1 plus R2 voltage exceeds 0.7 volt, C1 starts discharging. Q1 base current increases, Q2 collector current increases. When the voltage across R2 rises, the discharge current of C1 increases. Q1 base current grows, forming positive feedback. Q1 base voltage stays around 0.7 volt. C1 plus R1 voltage equals Q1 base voltage. When R2 voltage rises, C1 discharges to keep Q1 voltage stable. The faster R2 rises, the faster C1 discharges, and Q1 base current grows. When R2 exceeds 0.7 volts, C1 switches from discharge to reverse charge. Meanwhile, C2 starts charging, R2 voltage stops rising at 1.3 volt. Because Q2 saturation drop is 0.2 volt when voltage stops rising. C1 charge current drops, Q1 base and Q2 collector currents decrease. R2 voltage drops, C2 discharges through R2 and the LED C2 peak voltage is 0.6 volt. C2 is in series with the power source. C2 voltage plus supply exceeds 1.8 volt. The LED lights up when R2 voltage minus C1 voltage 0.6 volt. Q1 and Q2 turn off. C1 discharges through R1 and R2. When C1 discharges to 0 volt, it starts recharging. When C1 reaches 0.7 volt, Q1 turns on again. The process repeats. The LED keeps turning on and off. Above 50 Hz, the human eye won't notice flicker. C2 charging time equals LED off time. C2 discharging time equals LED on time when supply voltage increases. R2 peak voltage increases, capacitor charge or discharge time grows. The LED's average brightness stays nearly the same. This is how the circuit works.